Here we have the final lecture in the web series for non-parametric videos. Again, just to review, we're going to use non-parametrics in the situations where we have our dependent variable does not meet that assumption of normality, which is a major requirement here for non-parametrics, that we don't have large sample sizes, and that our interval level of measurement isn't met. So in these situations where you typically have ordinal dependent variables. Specifically, we're going to be dealing with the correlational non-parametrics. Now, both parametric forms, which we're learning in class, and non-parametric forms exist. The parametric form that we learned in class was called the Pearson product moment correlation coefficient. The most common non-parametric form of correlation is called the Spearman Rank Order Rho coefficient. Spearman formula is basically a computationally simplified version of Pearson's, and it deals with that ranking system that we saw introduced to us when we did the Mann-Whitney U and the different non-parametric t-tests and ANOVAs. A separate and conceptually different type of correlation is what's called a point by serial. I'm going to introduce the name and the basic of it, but really not spend much time on it, where a point by serial is used when one of the variables is continuous in nature and the other variable is dichotomous. And remember back from Research 610, dichotomous the di's prefix is 2. Basically, this is a 2-level variable. The researcher, however, has to make sure that they're writing a question that is not experimental in nature, trying to examine the means between two groups, but is in fact trying to examine the relationships between two levels. So you would not do a point by serial to see if salary differed between males and females. So that's about as much as we're going to talk about point by serial. The remainder of this is going to focus in on Spearman Rank Order Rho. Where Spearman Rank Order Rho is the non-parametric equivalent of Pearson, where Pearson requires that all of the variables be at least interval level of measurement, Spearman requires that they just all be at least ordinal with a sufficient number of categories, meaning that it should be continuous in nature, at least 4. It would be really hard to do a Spearman with only 3 levels. Point by serial, as I introduced last slide, has a dichotomous variable and an interval variable for the second one. Now let's talk a little bit about more of these rankings and where they come from, and maybe this will help clear up some stuff from earlier this semester. If we take a look, we see attitude towards the professor is one variable, and attitudes, I don't even know what this example would be, but an attitude is one example. All right, years of playing sport, I remember now. So satisfaction and attitudes toward the coach and years of playing the sport. And so we have everything 14 years, 12 years, 11 years, 12 years, so on. And then they're ranked. And we're going to look a little bit about these rankings, and these numbers are used to do the calculation. At this moment, what you're probably thinking is, I'm really glad I don't have to do this calculation by hand. So as we look through to break these down, let's take a look at how those ranks are created. And this is the same way that ranks are created in Mann-Whitney U and all of the other stuff we looked at earlier this semester, where scores are ranked from highest to lowest, and they're given a position. So notice all of these 5s are here, and 5 gets a 1, another 5 gets a 2, 3, 4, and then that 4 gets a 5, and the other 4 gets a 6. Well, 1, 2, 3, 4, and 5, or excuse me, 1, 2, 3, and 4 take up the first 4 positions, so they get a average rank of 2.5, whereas attitude here, 4 and 5, gets an average rank of 5.5. So those are going to be the scores that are entered in as the X values. For the Y values, we take range of years, go again from highest to lowest, where 14 years gets the position of 1, then 12 and 12 gets the position of 2 and 3, and the 3 11s get 4, 5, and 6. So 14 gets that rank of 1, because there's 12 and 12 are splitting, they get the rank of 2.5, and then 4, 5, and 6 gets that rank of 5. So now our XY correlation is the correlation of this X to this Y. So these are the two lines that would be correlated in SPSS. So mathematically, the formula should be relatively straightforward, and we plug our numbers in that were shown in the couple slides previously. And the problem is we get this number of 0.11, and we see this does not match our correlation of negative 0.47 or 447. So the standard formula that's simplified really just doesn't match SPSS. The problem is because we had so many tied ranks. In the next slide, I'm going to show you the formula that adjusts for that. You don't need to know it, but I just want you to see that there is an adjustment, and that's what happens and why non-parametrics are used as the more conservative version of an analysis, is because adjustments are made. Before I do that, I just want to talk a little bit about this SPSS output. It looks basically like a Pearson output. It just says Spearman up here instead of Pearson. You still start off with a correlation coefficient on that first line. We get our sig or p-value on the second line, and we have our sample size on the third line. Since that sig is 0.374 above 0.05, we would say that we would say that there was no significant linear relationship, and we would accept the null hypothesis, even though we have a moderate correlation there. Here's that formula I was talking about. This is it deals with dealing with for x and y, the different ties for x and y and the adjustments that have to get made, and as it breaks through those adjustments, eventually r sub s, which is the way that we write for Spearman as opposed to r where we use Pearson. Once we make all these adjustments, calculate them all, we now get that negative 0.45 that would match SPSS. When you do report Spearman, or if you see it in the literature, you'll see r sub s. And then it's all just interpreted the same way we did Pearson correlations. We do intensity in the same way, where it's 0 to negative 3 is that weak, 3 to negative 6 is moderate, above 0.6 is strong. We interpret the direction in the same way, where if it's a positive correlation, as one goes up, the other goes up, as one goes up, the other goes down, would be a negative direction. They still range from -1 to +1. You would write hypotheses, findings, and conclusions just like you would for a Pearson correlation. So that finishes up all of our non-parametrics. Make sure you take the self-quiz and be ready to answer questions on the test.